The universe is full of inspiring, mysterious, and sometimes terrifying phenomena. Among these are some of the most powerful and energetic events known to science. Supernovae. These massive stellar explosions generate more energy in a moment than a billion suns, releasing tremendous amounts of radiation across the electromagnetic spectrum, from radio waves to gamma rays. These explosions are so intense that the entire universe could, in theory, one day feel the effects of just one. A recent discovery by the James Webb Space Telescope, JWST, humanity's latest tool for peering into the cosmos, has caused a stir in the scientific community. The star Betelgeuse, a familiar and prominent figure in our night sky, is showing signs of an impending supernova. Could we be on the verge of witnessing one of the most incredible cosmic events within our lifetimes? Before we unravel the mystery surrounding Betelgeuse, it's essential to understand the significance of another monumental event in the history of astronomy, the explosion of supernova SN 1987A. This event has served as a key reference point for understanding the life cycles of massive stars like Betelgeuse and the catastrophic yet beautiful ends they eventually meet. Supernova SN 1987A, discovered in 1987, is one of the brightest and closest stellar explosions observed in centuries. It took place 168,000 light-years away in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. When it exploded, SN 1987A released a tremendous amount of energy and became visible to the naked eye from Earth. Since that initial discovery, astronomers have closely followed the expanding debris of the supernova, using it to gain insights into the processes involved in stellar evolution and death. What makes SN 1987A particularly important is that it has been a subject of detailed study using many different space-based observatories, such as NASA's Hubble, Spitzer, and Chandra telescopes. Now, the JWST has taken this research to new heights with its unparalleled ability to see in the infrared. JWST has captured the most detailed images yet of SN 1987A's structure, including its equatorial and outer rings, a crescent-shaped inner ejecta, and a curious keyhole-like structure at its core. One of the most interesting features of SN 1987A is its inner equatorial ring, which was formed by debris that the star expelled tens of thousands of years before the supernova event itself. When the supernova shock wave hit this structure, glowing hotspots formed, visible in JWST images. The telescope also revealed crescent-shaped structures in the outer layers of gas, likely remnants of the original star's explosion. This explosion, which likely marks the end of a blue supergiant star, one of the most massive and luminous stars in the universe, serves as a cosmic laboratory. By studying SN 1987A, scientists have been able to piece together the final moments of a star's life and draw conclusions about how future supernovae might behave, including Betelgeuse. Betelgeuse, located in the constellation Orion, is one of the brightest stars in our night sky. It is also one of the largest, with a diameter around 900 times that of our Sun. If placed at the center of our solar system, its outer surface would extend well beyond the orbit of Jupiter. Betelgeuse is a red supergiant, a massive star in the late stages of its life. Astronomers have known for some time that Betelgeuse is destined to explode in a supernova event. However, it made headlines in 2019 and 2020 when it suddenly began to dim. While stars like Betelgeuse do naturally vary in brightness, the rapid and significant dimming alarmed astronomers. This dimming event, observed by multiple instruments including the JWST, raised questions. What could be causing it? Was this a sign that Betelgeuse was about to go supernova? Several theories have been put forward to explain Betelgeuse's sudden dimming. One theory suggests that the dimming was caused by a large cloud of dust passing in front of the star. As massive stars like Betelgeuse age, they shed their outer layers, producing huge amounts of dust and gas. These ejected materials can obscure the star's light, making it appear dimmer from our vantage point on Earth. Another possibility is that Betelgeuse is undergoing regular stellar pulsations. Massive stars often experience periods of expansion and contraction, leading to changes in brightness as the outer layers move closer together or farther apart. But the most tantalizing theory is that the dimming could be a precursor to a supernova. Betelgeuse, at 20 times the mass of our Sun, is nearing the end of its life. As it runs out of fuel, its core will eventually collapse under its own gravity, triggering a massive explosion. Historically, stars have been observed to undergo unusual dimming events before exploding into supernovae. Could Betelgeuse be on the verge of such an event? The implications of a Betelgeuse supernova are profound. If Betelgeuse were to explode, the supernova would be one of the most significant astronomical events witnessed in human history. The explosion would produce a burst of light so bright that it would be visible from Earth even during the day, for weeks or even months. Betelgeuse would outshine every star in the night sky, becoming a brilliant beacon in the heavens. But the explosion would have more than just visual effects. Supernovae release massive amounts of energy in the form of radiation and high-energy particles. The gamma radiation produced by the Betelgeuse supernova would be detected across the universe. However, given Betelgeuse's distance from Earth, approximately 642 light-years, the radiation would not pose a threat to our planet. The shock wave from the explosion would also travel through space, pushing and compressing the interstellar medium, creating a glowing bubble of ionized gas that would persist for thousands of years. The ejected materials would enrich the surrounding region with elements like carbon, nitrogen, oxygen, and metals, elements crucial for the formation of new stars, planets, and potentially life. Astronomers would have a once-in-a-lifetime opportunity to study a nearby supernova in real time. The data collected would provide invaluable insights into the life cycles of massive stars and the mechanics of stellar explosions. Observing Betelgeuse's demise could even help us understand the ultimate fate of other massive stars in the universe, as well as the creation of the heavy elements that make up planets, moons, and living organisms. What's next for Betelgeuse? The future of Betelgeuse remains one of the most fascinating and unpredictable mysteries in modern astronomy. Betelgeuse, a red supergiant in the constellation Orion, has captivated scientists and stargazers alike due to its immense size and the possibility that it could explode in a spectacular supernova. However, predicting exactly when this explosion will happen is not an easy task. Why is Betelgeuse's fate uncertain? Massive stars like Betelgeuse are inherently unpredictable in their final stages of life. While astronomers have some understanding of how stars evolve and die, the precise timing of a supernova is difficult to determine. One reason for this unpredictability is the complex physics happening inside Betelgeuse's core. As the star burns through its nuclear fuel, it goes through various stages of fusion, creating heavier elements. Once it starts fusing iron in its core, the star will collapse, triggering a supernova. However, pinpointing exactly when Betelgeuse will begin fusing iron, and therefore explode, is extremely challenging. The dimming event that occurred in late 2019 and early 2020 sparked widespread speculation that the supernova might be imminent. The star's brightness dropped by over 60% within just a few months, leading many to believe that it could be on the verge of collapse. This phenomenon was dubbed the Great Dimming and triggered a flurry of observations and theories. Some scientists hypothesized that the dimming was a sign that Betelgeuse was entering its final stages, while others proposed that it could be caused by surface activity or dust clouds obscuring the star's light from our vantage point on Earth. Although Betelgeuse eventually returned to its normal brightness, this event highlighted just how unpredictable the star's behavior can be. The dimming was a reminder that massive stars like Betelgeuse can undergo dramatic changes in a short period of time. How little we truly know about the specific signs leading up to a supernova. The role of the James Webb Space Telescope, JWST, in monitoring Betelgeuse has become crucial. Astronomers have turned to advanced space-based instruments to better understand Betelgeuse's future. One of the most important tools in this effort is the JWST, which was launched in December 2021. Equipped with state-of-the-art infrared sensors, JWST is capable of observing stars and other celestial objects in unprecedented detail. By studying Betelgeuse's light, heat, and radiation emissions, scientists hope to uncover more about its internal processes and whether the supernova might be closer than we think. One of the primary benefits of JWST is its ability to see through cosmic dust, which can obscure visible light. This is crucial for observing red supergiants like Betelgeuse, as they tend to expel large amounts of gas and dust in their final stages of life. JWST's sensitivity to infrared wavelengths allows it to detect subtle changes in the star's environment, giving astronomers a clearer view of any potential changes that may signal an impending explosion. In addition to monitoring Betelgeuse's brightness and temperature, the telescope can also analyze the star's spectrum. By doing this, astronomers can identify the chemical elements present in Betelgeuse's atmosphere and the rate at which they are being expelled. This information helps scientists track the star's evolutionary stage and estimate how much longer it might have before its core collapses. If Betelgeuse is nearing the iron fusion stage, JWST instruments will likely detect this transition, providing the first concrete evidence that a supernova is imminent. Astronomers expect to observe certain telltale signs before the actual explosion. One of the key indicators would be a rapid increase in the star's neutrino emissions. Neutrinos are nearly massless subatomic particles produced in huge quantities during the nuclear reactions inside stars. When a star like Betelgeuse begins its final collapse, it will emit an intense burst of neutrinos that could reach Earth within hours, providing an early warning of the coming explosion. Observatories around the world, including neutrino detectors like Japan's Super Kamiokande, are constantly monitoring the universe for these signals. Should a significant spike in neutrinos be detected, astronomers would have a brief window of time, possibly just a few hours or days, before Betelgeuse's light reaches Earth, allowing them to prepare for the event and mobilize observational resources. The burst of neutrinos would precede the visible explosion because neutrinos travel almost at the speed of light and can pass through matter with very little interaction, unlike photons, which can be delayed by gas and dust. The detection of this neutrino burst would not only confirm the imminent supernova but also provide invaluable data about the core collapse process in massive stars. When Betelgeuse does finally explode, the event will be nothing short of spectacular. Supernovae are among the most energetic events in the universe, releasing more energy in a matter of seconds than the Sun will produce over its entire 10 billion-year lifetime. Because Betelgeuse is located relatively close to Earth, about 640 light-years away, the explosion will be visible even during the day and will shine as brightly as a full moon in the night sky for weeks or even months. The light from Betelgeuse's supernova will dominate the sky, drawing the attention of both professional astronomers and amateur stargazers. Its brightness will gradually fade, but the remnants of the explosion will continue to glow for thousands of years as the debris expands outward and interacts with the interstellar medium. The resulting supernova remnant could become a new nebula, much like the famous Crab Nebula, which was created by a supernova observed in 1054 AD. The explosion will provide an unprecedented opportunity for astronomers to study a supernova in detail. Since Betelgeuse is one of the nearest stars to Earth that could go supernova, its proximity will allow for high-resolution observations that are not possible with more distant stars. Scientists will be able to study the star's core collapse, the shock wave generated by the explosion, and the formation of a neutron star or black hole in its aftermath. These observations will help refine our understanding of stellar evolution and the life cycles of massive stars. While the sight of Betelgeuse exploding will be awe-inspiring, the physical impact on Earth will be minimal. Betelgeuse is far enough away that the radiation from the supernova will not pose any threat to life on our planet. Although supernovae can emit dangerous levels of gamma radiation, which can strip away a planet's atmosphere and cause mass extinctions, Betelgeuse is located too far from Earth for this to happen. However, there could be some minor effects on our planet's upper atmosphere. For instance, the influx of high-energy particles from the explosion might cause disruptions in satellite communications and navigation systems. These particles, along with the supernova shock wave, could also interact with Earth's magnetic field, creating dazzling displays of auroras that might be visible much farther from the poles than usual. While these effects would be temporary, they would add to the drama and wonder of the event. Beyond the immediate spectacle and scientific data, Betelgeuse's supernova will have profound implications for our understanding of the universe. Supernovae play a critical role in the cosmic cycle of matter, dispersing elements like carbon, oxygen, and nitrogen into space. These elements are essential for the formation of new stars, planets, and even life itself. In a very real sense, the death of massive stars like Betelgeuse is what makes life possible. The explosion of Betelgeuse will also offer a rare chance to study the chemical enrichment of the interstellar medium in real time. By analyzing the ejected material from the supernova, scientists can trace the origins of various elements and better understand how they are distributed throughout the galaxy. This knowledge could inform our understanding of the origins of life on Earth and the potential for life elsewhere in the universe. Finally, Betelgeuse's supernova will serve as a reminder of our place in the cosmos. We are quite literally made of stardust. Every atom in our bodies was forged in the heart of a star. The death of Betelgeuse will not only enrich our understanding of the universe, but will also reinforce the deep connection between humanity and the stars. The event will be a testament to the beauty, power, and fragility of the universe, inspiring future generations to continue exploring the mysteries of the cosmos. In the end, the question of when Betelgeuse will explode remains uncertain. The star's erratic behavior, including its dramatic dimming in 2020, has raised hopes and concerns that the supernova might occur within our lifetimes. However, it's equally possible that Betelgeuse could continue burning for thousands of years before its final collapse. Regardless of the timeline, astronomers will continue to monitor the star closely using instruments like the James Webb Space Telescope to gather data and search for clues. When the moment finally arrives, Betelgeuse's supernova will be an event for the ages, one that will not only captivate the world but also advance our understanding of the universe in ways we can scarcely imagine. Until then, we wait, watch, and wonder what's next for Betelgeuse.